Everyday device myths. Incognito mode makes you anonymous. It doesn't. When you open an incognito or private browsing window, your browser stops saving your history, cookies, and form data on that specific device. That's it. Your internet service provider can still see every website you visit. The websites themselves can still see your IP address, which reveals your approximate location. Your employer or school can monitor your activity if you're on their network. Browser fingerprinting can still track you based on your device settings, screen resolution, installed fonts, and dozens of other data points. Incognito mode is just local cleanup. It hides your activity from someone using your laptop later, not from the internet itself. Charging your phone overnight ruins the battery. Modern smartphones have charging circuits that stop pumping electricity into the battery once it hits 100%. The myth comes from older nickel-cadmium batteries that suffered from overcharging. Lithium-ion batteries, which every smartphone uses now, don't have this problem. In fact, many phones use optimized charging that learns your sleep schedule and deliberately slows down around 80%, then finishes charging right before you wake up. This reduces the time spent at full charge, which actually extends battery lifespan. What does damage batteries is heat. Charging under a pillow or in direct sunlight causes more harm than leaving it plugged in overnight ever will. Macs can't get viruses. Apple computers are vulnerable to malware, ransomware, adware, and every other type of malicious software. The reason Macs historically had fewer viruses wasn't immunity, it was market share. Windows dominated, so attackers targeted Windows. As Macs became more popular, attacks increased. macOS has built-in protections like Gatekeeper and Xprotect, but so does Windows with Defender. Neither system is invincible. Macs face threats from Trojans disguised as legitimate software, browser-based exploits, and phishing attacks that don't care what operating system you're running. Closing apps saves battery. Forcing apps to close on your phone often wastes more battery than leaving them alone. iOS and Android suspend background apps automatically. They sit in memory doing nothing, consuming almost zero power. When you force quit an app and reopen it, the operating system has to reload everything from scratch. That startup process uses more energy than just resuming a suspended app. The exception is apps that are genuinely misbehaving, constantly refreshing in the background, or using location services non-stop. But those are rare cases. For normal apps, let the system manage them. Internet and network myths. The internet is in the cloud. The cloud is just someone else's computer. When you save a file to the cloud, it gets stored on physical hard drives inside massive data centers owned by companies like Amazon, Google, or Microsoft. These buildings are filled with servers, cooling systems, and backup power supplies. The internet itself is a global network of undersea cables, fiber optic lines, cell towers, and routers. Data travels through physical infrastructure. There's no floating nebula of information. The term cloud is marketing. It makes remote storage sound magical when it's actually just renting hard drive space on a server farm in Virginia or Ireland. Wi-Fi and internet are the same thing. Wi-Fi is a local wireless connection between your device and your router. The internet is the global network your router connects to through your internet service provider. You can have Wi-Fi without internet. If your modem loses connection but your router still works, your devices stay connected to Wi-Fi but can't reach the internet. You're connected locally but isolated globally. People confuse the two because Wi-Fi is how most devices access the internet, but they're separate technologies. Your router creates the Wi-Fi network. Your modem connects that network to the internet. 5G causes cancer. Radio waves from 5G networks are non-ionizing radiation. They don't have enough energy to break chemical bonds or damage DNA. Ionizing radiation like X-rays and gamma rays can cause cancer because they rip electrons off atoms. Non-ionizing radiation like radio waves, microwaves, and visible light doesn't do that. The frequency range used by 5G sits between 600 MHz and 100 GHz, far below the threshold needed to ionize atoms. Decades of research on radio frequency exposure show no link to cancer at the power levels used by cellular networks. The myth gained traction during 5G rollouts because people saw new towers and assumed new danger, but the physics hasn't changed. VPNs make you 100% untraceable. A virtual private network encrypts your internet traffic and masks your IP address by routing it through a server owned by the VPN company. Your internet service provider can't see what websites you visit, only that you're connected to a VPN server. The websites you visit see the VPN server's IP address instead of yours, but the VPN company itself can see everything. If they keep logs, your activity isn't anonymous. Law enforcement can subpoena those logs. Browser fingerprinting can still identify you. Payment methods tied to your VPN account link back to you. VPNs add a layer of privacy, not invisibility. Performance myths. A fast processor means a fast computer. The central processing unit is one component in a system. If you pair a high-end processor with a slow mechanical hard drive, the computer will feel sluggish because every file operation waits for spinning platters. If you have 4 gigabytes of RAM and try to run 20 browser tabs, the system will crawl regardless of processor speed because it's constantly swapping data to the hard drive. A fast graphics card won't help if you're just browsing the web. Bottlenecks exist everywhere. A computer is only as fast as its slowest critical component for the task you're doing. More RAM always makes your system faster. Adding memory helps when you're running out. If your computer uses 6 gigabytes of RAM and you have 8, upgrading to 16 will improve performance because you'll stop hitting the ceiling. But if you're using 6 gigabytes and already have 32, adding more does nothing. Unused RAM is wasted RAM. The operating system will use available memory for caching and background tasks, but beyond a certain point, you won't notice the difference. Diminishing returns hit hard. Going from 4 to 8 gigabytes is transformative. Going from 64 to 128 is imperceptible for most users. Solid-state drives always feel faster. An SSD improves boot times, application launches, and file transfers because it has no moving parts. But once an application is loaded into RAM and running, the storage drive doesn't matter anymore. Gaming performance depends on the graphics card and processor, not storage speed, unless the game is streaming assets constantly. Video editing benefits from fast storage because you're reading and writing massive files. Web browsing doesn't. An SSD is a major quality of life upgrade, but it doesn't accelerate every task. NVMe always feels faster than SATA. NVMe drives use the PCIe bus and can hit read speeds above 7,000 megabytes per second. SATA solid-state drives cap out around 550 megabytes per second. On paper, NVMe is over 12 times faster. In practice, most people can't tell the difference in daily use. Both boot windows in seconds. Both open applications instantly. The gap shows up in benchmarks and specific workloads like transferring huge video files or running virtual machines. For typical tasks, SATA solid-state performance is already faster than human perception can register. Graphics cards don't improve general speed. A dedicated graphics processing unit renders images, processes video, and handles 3D calculations. It doesn't speed up web browsing, word processing, or file management. Those tasks rely on the processor and RAM. Gaming and creative work benefit massively from a strong graphics card. Everything else ignores it. Data and privacy myths. Your data is encrypted by default. Most data sitting on your phone or computer isn't encrypted unless you specifically enable it. Photos, documents, and messages are stored in plain files that anyone with physical access can read if they bypass your lock screen. Cloud services vary wildly. Some encrypt files during transfer but store them unencrypted on their servers. Others encrypt everything but hold the decryption keys themselves, meaning they can access your data whenever they want. True end-to-end encryption means only you hold the keys, but most services don't work that way. Encryption in transit protects data traveling over networks. Encryption at rest protects stored data. Most consumer services only do the first one. Apps only collect what they need. Applications collect far more data than their core function requires. A flashlight app doesn't need your location, contacts, or microphone access, but many request those permissions anyway. The data gets sold to advertisers, analytics companies, and data brokers. Free apps make money by monetizing user information. Even paid apps sometimes collect excessively. Reading the permission request tells you what an app wants access to, but not what it does with that access. Location data can be used to build movement patterns. Contact lists can map social networks. Microphone access enables voice profiling. Deleting data removes it. When you delete a file, the operating system marks that storage space as available, but doesn't erase the actual data. It's still there until something overwrites it. Recovery tools can pull back deleted files easily. Even formatting a drive doesn't guarantee erasure. Solid-state drives complicate this further with wear-leveling algorithms that move data around invisibly, leaving copies in inaccessible areas. Secure deletion requires specialized software that overwrites the space multiple times with random data. On cloud services, deleting a file from your account doesn't delete it from the company's servers immediately. Backups, server caches, and retention policies keep copies for weeks or months. Accepting all cookies is harmless. Cookies track your behavior across websites. First-party cookies come from the site you're visiting and remember your login or preferences. Third-party cookies come from advertisers and trackers embedded in that site. They follow you across the internet, building a profile of your interests, habits, and demographics. That profile gets sold and resold. Rejecting third-party cookies limits cross-site tracking. Accepting all cookies gives dozens of companies permission to monitor you. The banners exist because of privacy laws forcing disclosure. Not because cookies are optional. They've always been there. Now you just get asked. AI and automation myths. Artificial intelligence understands information. AI systems recognize patterns in data without comprehending meaning. A language model predicts the next word based on statistical likelihood from its training data. It doesn't understand the concept behind the words. An image recognition system identifies a cat because it matches visual patterns associated with the label cat in thousands of training images, not because it knows what a cat is. There's no internal meaning, just correlation. The system mimics understanding by producing outputs that look intelligent, but the process is pattern matching at scale. AI thinks like humans. Human thinking involves consciousness, subjective experience, reasoning from first principles, and understanding causation. AI systems use mathematical operations on numerical representations of data. A neural network applies weighted calculations across layers until it produces an output. There's no internal monologue, no pondering, no eureka moments. The architecture is fundamentally different. Humans reason with mental models of how the world works. AI systems optimize mathematical functions. The results can appear similar, but the mechanisms have nothing in common. AI learns like humans. Machine learning requires thousands or millions of examples to identify a pattern. A child sees a few dogs and understands the concept. AI training involves feeding massive datasets through algorithms that adjust parameters until error rates drop. Human learning involves observation, experimentation, reasoning, and building mental frameworks. You can explain a new concept to a person with words. AI needs numerical data processed through gradient descent. Humans generalize from minimal examples. AI needs exhaustive coverage to handle edge cases. AI is unbiased. AI inherits biases from its training data. If hiring algorithms are trained on historical hiring decisions made by biased humans, the algorithm learns those biases. Facial recognition systems perform worse on darker skin tones because training datasets contained fewer examples of diverse faces. Language models reproduce stereotypes present in their source text. The math itself is neutral, but the data isn't. Bias in, bias out. Even well-intentioned developers struggle to eliminate these issues because bias is embedded in historical records, language, and cultural assumptions that permeate training data. AI stores memory. AI models don't remember individual interactions unless explicitly designed to. A conversation with a chatbot doesn't persist beyond that session unless the system saves the text separately and feeds it back in later. The model itself doesn't retain your questions. During training, the model adjusts its internal parameters based on patterns in data, but it doesn't store the data itself. It's like learning to recognize faces without remembering every face you've ever seen. Some systems have external memory mechanisms bolted on, but the core model operates statelessly. System reality myths. Software is neutral. Every piece of software embodies choices made by its creators. The features included, the features excluded, the default settings, the interface design, and the underlying algorithms all reflect priorities and assumptions. A social media feed algorithm that prioritizes engagement over accuracy isn't neutral. It's optimized for a specific goal that has consequences. Software that requires certain hardware excludes people who can't afford it. Accessibility features that aren't built in from the start marginalize disabled users. Neutrality implies no impact, but software shapes behavior, attention, and access. Algorithms are fair. Algorithms execute rules, but the rules themselves encode human decisions about what matters. A credit scoring algorithm that weighs zip code heavily will disadvantage people in poor neighborhoods regardless of individual creditworthiness. A content moderation algorithm trained primarily on English will perform worse in other languages. Fairness requires defining what fair means, and that definition is subjective. Equal treatment can produce unequal outcomes when starting conditions differ. Algorithms optimize for measurable objectives, but those objectives might not align with fairness as humans understand it. Digital systems are precise. Computers use binary and floating point arithmetic that introduce rounding errors. When you add 0.1 plus 0.2 in most programming languages, you don't get exactly 0.3 because those decimal numbers can't be represented precisely in binary. Spreadsheets accumulate tiny errors across millions of calculations. GPS coordinates are accurate to within meters, not millimeters. Timestamps can drift between systems. Digital precision is impressive compared to analog methods, but it's not absolute. Every measurement has limits, every calculation has error margins, and every system has tolerances. Digital equals permanent, data degrades, hard drives fail, file formats become obsolete, cloud services shut down, websites disappear. The internet isn't archived completely. Most content vanishes within years. Physical media decays, CDs delaminate, flash drives corrupt, magnetic tapes deteriorate. Digital preservation requires active maintenance, migrating data to new formats and new storage as technology changes. Permanence is an illusion. Digital data only persists as long as someone actively maintains it. Neglect equals deletion, just slower than hitting the trash button. Digital equals controllable. Complex systems behave unpredictably. Software has bugs. Networks have latency. Updates break things. Automation fails in unexpected ways. The more interconnected a system becomes, the harder it is to predict how changes propagate. A minor configuration change can cascade into a global outage. Digital tools give the appearance of total control because you can specify exact parameters, but emergence, edge cases, and unforeseen interactions create chaos. Control is partial, temporary, and constantly threatened by complexity. And while you're busy trying to control your own systems, tech companies have already built 7 different layers to track everything you do. That breakdown is in the next video.